Section 6-6, Part 2, Solving a System of Equations by Subtraction. Solve the system by subtraction. So here I have 3x minus y equals to 4 and 2x minus y equals to 1. You notice that your y terms and your x terms are lined up, your equal signs are lined up, and your constants are lined up. To use the subtraction method, you must have the variables lined up, equal signs lined up, and your constants. Notice that these are the same. When they're the same, you will use subtraction, which we're being told to use subtraction on this problem. So we're going to be subtracting each one of these. So we must use our subtraction sign. 3x minus 2x. Pull it to the side if you have to. 3x minus 2x gives you 1x. 3x minus 2x gives you 1x. Okay, so I end up with 1x. Now I have negative y minus negative y. So negative y minus negative y. We're subtracting. Anytime you have that minus the negative, that's adding the opposite. You must change both of those to their opposite. That becomes negative y plus positive y. So when you're adding with unlike signs, you subtract and take the sign of the larger. So you get 0y. So the y's cancel. So negative y minus negative y gives you 0y, or just 0, equals to 4 minus 1 gives you 3. So therefore, we have found what x is. We're looking for the point of intersection. So I know right now my point of intersection's x value is 3. Now we must find y. To find y, we will take what x is and plug it back into either one of these original equations in for x. So I'm going to plug it back into the first one. I'm going to plug it back into the original equation, the first one. So let's take what x is in this, what we found x to be, and plug it into this equation. So I have 3 times 3 minus y equals to 4. That gives me 3 times 3 is 9 minus y equals to 4. Multiply here. 3 times 3 is 9 minus y equals to 4. You're solving for y, so get the y on one side by itself. So I need to subtract 9 from both sides. 9 minus 9, those cancel. I end up with negative y equals 2. Punch in your calculator. 4 minus 9 gives you negative 5. Divide both sides by negative 1. You're not finished until you get a positive 1 in front of y. So you have to divide both sides by negative 1. Therefore, y is equal to positive 5. So y equals to 5. So I'm going to take the value of y, which is 5, and plug it into my answer. So therefore, the point of intersection we found to be 3, 5. Now we want to check it. We want to check it always. So I'm going to plug it back into the original problem, making sure the left side equals the right side. Okay? So I'm plugging in the point 3, 5. That was our answer, 3, 5. So let's test 3, 5. X is 3, y is 5. So plugging it in, this would be 3 times x, which is 3, minus y is 5, equals to 4. The question is, does the left side equal the right side? So 3 times 3 is 9, minus 5 gives you 4. Is 9 minus 5 4 also? Yes, it is. So therefore, my answer does satisfy the first equation. So let's see if our answer satisfies the second equation. So substituting in, x is 3 and 5 for y. That's 2 times x, so that's 2 times 3, minus 5. Does that give me 1? Well, 2 times 3 is 6, multiplication before subtraction. So I have 6 minus 5 equals to 1. 6 minus 5 is 1. So does the left side equal the right side? Yes, it does. So we solve this system of equations by subtraction, and our final answer is 3, 5.